Hello and welcome back. So today I'll be talking to you about the classification algorithms, mainly the intuition behind it. So as you know, AI today, if you give it an image of a dog and a cat, it will know that, this is a dog and this is a cat and these are different. So rather than thinking that AI is now, thinking, or the machine learning behind it, there is a person behind it, let's see how this model trains and then the mechanism behind this detection. So what are the applications of classifications? Of course, spam filtering, sentiment analysis, object detection, anomaly detection, etc. The data type that can be classified: images, text, audio, code, time series, tabular data, videos, graphics, etc. Graphs or networks. Who can benefit from this video? Everyone using AI, because either you are using it and it would be good to know how it is doing this such that you can think about it better, or you are a young data scientist who will build products or services from it, and this would allow like fixing problems or fixing any hallucinations, or trying to think beyond the external usage. And of course, executives who would be managing teams, all of them now moving into AI to keep up with the intuition behind, to make better decisions. Prerequisites, assuming very little, just knowledge of Excel, general knowledge of logic, algebra, etc., high school level. All right, so how does it work? It goes in a couple of steps. So first one is converting the input into numbers. As you know that, mathematics is the queen of all the algorithmics. So first, for the computer to understand an image or text, it has to be converted into numbers. And how to do that? Like if I have a text or an image, very simply, one can think about it. I have an image of a cat and another image of a dog, or like I have a series of couple of images. I give, the cat image, let's say, 0, 1, and this is a vector that's illustrating the cat, and then the dog would be 1, 0. And if I have like 10 images, the first one would be 1, 0, 0, 0, 0. These are coordinates, right? We used to see it in 2D, could be 3D, could be any dimensions. So this is the first step. I will not go deep into this. It's called embedding for text, convolution for images, and it's a big field, but I need you to understand that any input will be transformed into a vector of numbers, and then it goes from there. And here I'm simplifying, and let's say I have two objects. One has coordinates 0, 1, and the other one has 1, 0. Okay, so this you can put it on the XY axis, and it's a dot. So this is the start. Now, how can I take it from there? If I can come up with a matrix multiplying object 1 leading to one value, and then I memorize this, I save this value, and then I take the same matrix, this is my model, then I multiply it by object 2, I obtain another value, then I know now, for example, a matrix multiplying the cat image will lead to the value 1, let's say, and then same matrix multiplying the dog image will lead to the value 2 or -1, let's say. As long as I know these two values, it's enough to input an image, do the embedding, like transform it into a vector. Then I have a model. I multiply. If I obtain 1, this is a cat. Obtain 2, or the other number, it's a dog. This is the intuition behind. And let's take it now some steps further to really see how can I find this matrix that's called the model. Okay, and by the way, when we say parameters, I'm giving you here a model with 4 parameters, and you hear about ChatGPT or these fancy models, 7 billion parameters, 3 billion parameters. It's same thing. It's a huge matrix or series of matrices that contain numbers, and they will multiply every input and will lead in a way to certain outputs. Of course, when it goes to ChatGPT, it's not only about classification, there are much more in it. Now, back to here. Okay, how to get, the whole thing is how to obtain these 4 parameters that will define my model. There are 2 ways. One of them is the analytical way, and the other one is the numerical way. Let me speak really quick about the numerical one. There is a method called gradient descent that practically really very simply, it will start from random numbers and try to minimize the error that's obtained from multiplying this matrix with the inputs until finding the 4 numbers that will lead to the right output. For example, if you assume here I want my output to be -1, 1. Okay, I keep playing with these numbers until I obtain -1, 1, and that's the model. Okay, that's the gradient descent, and it's everywhere. And this is how most of these models, and it's a huge concept though. Deeply going into it would be the subject of another video. Let me know if you're interested in the intuition behind. But now we'll focus about an easier one, which is the analytical way. Okay, let's say I have the matrix of the weights, and then I have object 1. So what I want is I multiply W by object 1 vector to obtain a C1, certain output, and I multiply the same model W by the object 2, I obtain a C2, which can lead to that the matrix W times a vector O that I will define from the concatenation, the merging of the 2 vectors, the input vectors. Okay, these are the training data. So my model will learn from these. I know the input, I know the output. Okay, and then later on we will see how to input a new input and then getting the classification. Now, so back to here, the equation becomes WO times O, like the matrix W multiplying the matrix O, defined like this, should lead to C, which is the outputs, or what we call the labels, right? So these are the training data, these are the labels, and here is the weights matrix for those learning linear algebra, data science right now. To solve the equation, very simple. So I need to multiply by inverse O from the right on both sides, and I'll obtain, so here WO times inverse O, O times inverse O is like X over X, or X times 1 over X, which will lead to 1. So similar with the matrix algebra, it will lead to this formula here, that W equals C times inverse O on the right side. Very good. So let's take a very simple numerical illustration, and as usual we go to Google Sheets. Okay, I'll assume my 2 objects are 0, 1 and 1, 0. Very simple. My so my matrix O will look like this, and I'll just take, you know, the matrix C, as what I want is for object 1 a label of -1, and for the object 2, okay, a label of 1. So if I obtain -1, I know this is object 1, I obtain 1, it's object 2. Okay, let's calculate the inverse of O, okay, to solve this formula that we figured out here. Very simply, and I'm using it, I'm doing it on Google Sheets because it's free. Everyone can verify, change the numbers, repeat, and then let it sink in 100%. So the matrix inversion, as we did the last time, I take just M inverse, and then of this matrix, matrix O, that's what I obtain. Then to calculate W, I multiply C by inverse of O, and this is my model. Congratulations, you just trained your model, okay, on the training set. Now I have my model here. I need to test. If I multiply this W by object 1, I should obtain -1, and then 1 if it's object 2. Very good. So to multiply, it's mmult, okay? So I multiply my matrix by the object 1, and look, I obtain -1, right number, and similar here. That's it. Trained our model, and then now we validated our model. Next, we need to take what we call out of sample. Like, instead of taking our inputs, our initial inputs, now I will take another object. I call it object 1, but something similar, that instead of 0 and 1, I'll take it 0 and 0.9. And then instead of 1 and 0, I'll take it like 1.1 and 0. So saying, instead of dog A, I'll take another dog B. And then for the cat A, I'll take another cat B. And it should still distinguish between the two. So I take my W, my matrix, and then I multiply again by object 1 and object 2. And as you notice here, there is 0 point, minus 0 point, like it should have been -1 and 1. Now it's -0.9 and 1.1. Very close. And this would tell you that, you know, I accept, this is like a probability, and I accept my numbers within a certain error. Like, as long as the error is less than, let's say, 10%, I'll accept it and then attribute to object 1 or 2. Voila. In Python, it becomes much easier. You just, you know, get your matrix W, and then you multiply by object 1 and multiply by object 2. Very simple, and that's how it becomes systematic. From our previous work, we used this to classify text and videos for 700 classes. Okay, but the model was 96% accurate or so, and even we went beyond that and created a classifiers model generator. So it's enough, like we made an engine that you can input a list of classes, okay, anything. It could be like cigar, you know, football, any topics, and then you will get a model automatically. It will generate. That was before GPT and all that 2022. It will create a model for you that classify that does very well. I hope that was beneficial, and credits to my teachers, Nassim Talib, Grant Sanderson, Luis Serrano, Steve Brunton, and many others. I hope you enjoyed this video. If you like it, please share, like, comment, subscribe, and if you have any questions, leave them in the comments. And if you have any suggestions for next simplification video, please leave them in the comments and I'll reply.